here we go. We're going to talk about limits here, and I've got a particular function, f of x here, and we're going to find certain values, and you can see that f of negative 3 here is 4. And now here's the question. We want to find what's the limit as x approaches negative 3. In other words, as x gets closer to negative 3, what happens to the y value? And you can see that if I picked a number that are close to negative 3 from the left, that this value of y gets closer and closer to 4. But if I check and I see what happens is I pick a value of x that gets closer to negative 3 from the right, the y value gets closer to negative 2. So therefore, the limit does not exist because it doesn't go to the same value from both sides. You can't say there is no limit in this particular, at this particular point. Now, we'll run through these pretty quickly. F of negative 1. F of negative 1 is 3. And what's the limit? As x gets closer to negative 1, from the left and from the right, that y value gets closer to 1. So in this particular case, there is a limit. It does exist. It's 1 as x gets closer to negative 1. And there is a point at f of negative 1, but they're not the same. So we will soon learn that that means that at that point the function is discontinuous, not continuous. F of 2. Alright, what's f of 2? Oh, look at that. It does not exist. There is no value. There's a hole right there at f of 2, so it does not exist. What's the limit, though, as x approaches 2? Well, as I get closer to 2 from, the left, the value of y gets closer and closer to 2. To 1. And if I looked at it from, this side, it gets closer to 1 as well. So the limit of this function as f of x gets closer to 2 is 1. So in this case, even though the point doesn't exist, there is a limit as x approaches that value. And finally, as what's f of 4? Well, you can see that f of 4 is 5. And what's the limit as x approaches 4? Well, you can see here that from the left and the right, the value of the y as x gets closer to 4 from both sides here gets closer. You can see this side gets closer to 5 and this side gets closer to 5. So the limit is 5. And you can see they're both the same. The value of the function at that point and the limit as x gets closer to that point is the same value. So we call that a continuous function. You don't have to pick up your pencil when you're drawing it. So it's continuous at that point. Here's another few limit questions here. And this one I don't have a graph, but I know how to graph this one myself, ln negative x, because I know how to, it's a pretty easy graph to make. So I'm going to use my graphing transformations. Here's ln x. It's the frisbee toss. Kind of looks like that. It has an asymptote right here at x equals 0. So if I want to graph f of ln of negative x, I know that that flips over, when I put that in there, it flips over the y-axis. So this is the graph that I am looking at, and that is h of x right here, f of negative x. So that's what I'm going to use to answer these particular questions. Now the first one here says, what is the limit as x approaches 0? Now this negative means from the left. So as x gets closer to 0 from the left, I can see as x gets closer and closer and closer to 0, the value of my function, well, it gets smaller and smaller and smaller, it looks like. So what we're going to say here, it really doesn't exist, but we're going to say that it gets closer to negative infinity. So it means that there is no limit, because infinity is not a limit. But this is how we describe it. It gets closer and closer to negative infinity. Now if I look at here, it says what happens is the function gets closer to 0 from the right. Now remember that this piece of the function doesn't exist over here really, because that was just helping me draw it. So as x gets closer to 0 here, it doesn't exist. There is no, because I can't put those values in the domain. Any of those values are not in the domain. So we're going to say d and e for that does not exist. And at the limit as x approaches 0, well, since it goes to negative infinity from the left and doesn't exist from the right, then overall it does not exist. There is no limit. Now here's a limit. I'm going to use my properties of limits, which you guys have all read about, to figure this one out. This one is not something easy I can graph, and sometimes if you can just plug in the value. So if I wanted to just plug in f of 0 here, because it's asking me, then that may give me the limiting value, but here I can see I can't put f of 0 in here because f of 0 doesn't exist because you can't divide by 0. So I can't put this in, so how am I going to figure out what this limit is? I can't graph it, so I'm going to use some little algebra tricks. So what we're going to do here is I'm going to figure this out. Alright, I'm going to say, alright, we want to know what the limit is as x approaches 0. So I'm going to do this little trick with this particular function. I'm going to rewrite this again. What I'm going to do is I'm going to take a little algebra trick and I'm going to multiply by a factor of 1, which isn't going to change anything. You might recognize this as the conjugate, because that's going to make my denominator easier to deal with here. So we're going to multiply by this number. In the purple, that's just multiplying by 1, which doesn't change anything. So what I'm going to get is I'm still finding the limit as x approaches 0. And what happens when you multiply these through? Well, you get x times that over, in the bottom, we're going to end up with 9, and then I'm going to get a plus and a minus, the same thing, 3 times root x plus 9, and then minus x plus 9. So let's see what happens. Don't forget I'm still trying to find what the limit is. So we're going to get 3x plus, actually, I don't want to multiply that out, I just want to leave it. So we're going to get x times 3 plus root x plus 9. I'm going to leave that factored. And on the bottom, I can see that I'm going to get minus x, because it would be 9 minus x minus 9. And here, these will cancel out. So it looks like I'm looking at what the limit is as x approaches 0 of negative 3 plus root x plus 9. Well, now this is a function that I could draw pretty easily if I wanted to, but I can picture in my mind that it would be a continuous function for certain values. I couldn't put anything less than negative 9, but 0 is not less than negative 9. So I am going to say, we're going to plug it right in. The limit as x goes to 0 would be, well, that would equal negative 3 plus 0. You plug that right in there, plus 9, which is going to be, sorry, there'd be some parentheses there because I got the negative. So this would be negative 6. So this thing goes to negative 6. If you want to, you can graph this function on your grapher, and you'll see as x approaches 0, the value gets closer to negative 6. I just grabbed this particular function right here. I graphed it on my graph, and you can do it on your graphing calculator, and you can see as x gets closer to 0 that in fact this function gets closer to negative 6. You can see that, Oops. Let's practice here. Alright, last thing I'm going to talk to you about is limits to infinity. What happens is, that's basically talking about the end behavior, what happens at the ends of a graph. So here's a simple example. We have this particular function, it's 7th degree polynomial, and the value of the leading coefficient there is positive, negative 4. So you guys, we don't really have to draw this perfectly, but I know that at the ends of this graph, it's degree 7, so it's going to either start down here, it's positive, it's going to make several turns, who knows how many, and then it's going to end up here because it's an odd function. So this thing, I don't really need to know. It looks something and then would end up like that. So now I can answer this particular question. What happens as x goes to negative infinity? Well, as x goes to negative infinity, as x gets closer and closer to negative infinity, the value of the y gets closer and closer, to negative infinity as well. So even though this limit doesn't exist, we describe it as going to negative infinity. And what happens when x gets closer and closer to positive infinity? You can see here, as x gets bigger and bigger and bigger, y gets bigger. This one explodes, so it gets closer and closer to positive infinity. So you have to remember that this means that there is no limits, but we describe them as getting closer to negative infinity and positive infinity. Okay, that's it for today.